Okay, great. All right. Hello, everybody. Do we want to get started then?
Yeah.
Okay.
All right. And Roesler, I also trying to software on involved in it here to talk to us about what the, I guess, solicit us for some ideas on other things.
Right.
I'll let Dan take it away.
Okay. Hi, everybody. So I am the co-founder and CTO of a company called UtilityAPI, but I'm not going to be focusing on that today. I'm going to be focusing on kind of my hobby side stuff, which is the Cleanweb initiative. So the Cleanweb initiative is basically clean tech software. So you hear about clean tech being like modules and improved nuclear and all that sort of stuff. But there's a whole realm of software-related products in the clean tech realm. And we like to call that Cleanweb because it's building off of the technology that was developed to create the internet and to create network communications. So a little bit of background on me. I'm originally a chemical engineer from UT Austin, and so surprisingly, the vast majority of my graduating class went into the oil industry. And instead of doing that, I actually went to work for an air quality testing company, and I was climbing smokestacks for 3 years out of college. So we basically tested all of the air emissions coming out of smokestacks around the country. And so I started out on the air quality testing side, and I've eventually moved into the clean tech side. In between, though, I was the CTO of a fitness app called Fitocracy. So that was a fitness app where you kind of gamified your fitness, you logged your workouts, and that's where I kind of got my tech programming skills from. So I'm combining those two with this startup called UtilityAPI, and UtilityAPI is basically a API that wraps utilities so that you can interact with the utility via API, which they currently don't have, and we don't see them having any incentive to have, so we're just making it. It's very similar to like a Twilio for telecom. So if you need to interact with the telecom, you can do that via Twilio. You just send a text message via API. We're doing that with utilities. So you can just access energy information via API and put in information into the utility via API. All right, but I'm not going to be talking about that. I'm going to be talking about clean tech software. And how many people know much about climate change or the science behind it? Okay, good, because I'm actually going to do a little bit of that. Okay, so to start off, and of course, obligatory disclaimer, I'm a volunteer for Cleanweb SF. It's a meetup in the Bay Area. We focus on spotlighting local startups in the Bay Area that are focused on clean tech software. And I don't represent, so you can't sue me for any of this information. It's all gonna be true, and I'm very confident about that, but this is my opinion. Okay, so everything that I will say in this presentation will happen in the next 35 years. So it looks like everybody will still be alive then in this room. So, all right, what you're going to experience over the next 35 years is what I'm gonna talk about. So this is not next generation stuff, this is this generation stuff. So this is the IPCC carbon cycle diagram, and it's super complex. And I don't expect you to read it, but basically this categorizes how carbon moves throughout the ecosystem. And so this is I was a chemical engineer, so I studied this a lot. But the red lines are what you kind of need to pay attention to. And the black lines, okay, so there's 200 gigatons of carbon that leave the planet and go into the atmosphere every year. And then there's 200 gigatons of carbon that go from the atmosphere and get absorbed via plants, via algae, et cetera, into the oceans and land, okay? And so that's basically the way the carbon cycle works. Now, we are taking sequestered carbon. So the sequestered carbon is things like coal, oil, natural gas, so carbon that has been put down in the earth or, over time, and we are taking that and we are injecting it into this carbon cycle. And that's how the greenhouse gas effect works. You add about 8 gigatons of carbon per year to the carbon cycle. And so that's basic science of how climate change came to be. So 8 gigatons of carbon per year, that's kind of the statistic that you want to remember out of this if you want to dole it out at a party or something like that. So it's about 280 gigatons by 2050. So that's in the next 35 years. Okay? The impact. All right. So now we're getting in a little bit more local. So this is California from 3 years ago to currently. And the expectation is that this will become the new normal from now on. So I think Governor Jerry Brown just instituted a 25% reduction, mandatory reduction, which is the first time that's ever happened, on residential or municipality water consumption across the state. That is probably going to become the new normal. So this is, I think, so this is 1961 to 1990. This is the average temperature in California. This is in the 2050 range. So this is what we can expect to see over the next 35 years. And then this is beyond that if nothing changes. So this is bad. It's bad locally. It hurts, I think. I don't know what my next slide is. Okay, this is a global system. So this is from the latest IPCC report that kind of categorizes the next wave of impact that climate change will have. So that 8 gigatons of carbon per year is leading to stuff like this. And a lot of this on here, if you look at it, is red, which is human impact. This isn't polar bears, this is humans. Okay? Sorry, I'm being super depressing right now. We gotta like slog through this because I think there's a lot of opportunity. Sure. Okay, so I don't know if you can see the planet, or you can see the, like, it's North America, South America, et cetera. Can you, it's kind of hazy on there. And then the blue is physical systems. So that's things like glaciers melting and oceans levels rising, that sort of thing. And so and then the green is biological systems. So that's impacts on wildlife and forests. And then the red is human impact. So that's things like humans having to move off of islands, farming impacts, food shortages, et cetera. And so the bars are the impact level. So what type of impact, and then how high the bar is the level of impact. And I think most of these are high. So a high impact on glaciers would mean that there could be severe flooding down in the valley as glaciers start to fall off. You're seeing a lot of glaciers in the Arctic start to melt quite rapidly. So, all right. So impact financially, the White House just released in July 2014 an impact study on the effect of climate change beyond 2 degrees Celsius, which is kind of like the standard level. This is how we don't get affected, and we're already like very close to that level. So it looks like the estimation is going to be in the trillions of dollars. This is actually an extremely conservative estimate. I've seen stuff on the order of $10 to $20 trillion over the next 35 years. So anyway, that's also a harm as well. And when I talk to people, I try to not talk about wildlife or ecological effects. Yeah. Yeah, so that's aggregate over the, I would say probably that's on the order of a 50-year period. So it's not annual. This is annual. Yeah, exactly. A generational effect. Exactly. This is probably the graph that I like the best because it shows error bars. So this is where we are now, right about here. And then this is the probability with no change to current behavior. And then this is change with current, or change or idealized change. And then this is the 2 degrees Celsius max that I referred to earlier. Okay, so 2050 is right where we cross that. And so that's kind of in our lifetime. It's something we are going to experience, and we're going to have to deal with it. Yeah. Okay, so here's a fun fact. The last time carbon levels were this high, today, not 2050, the sea level was 75 to 120 feet higher than it is now. And so this is San Francisco right here. And if you look, that's 100 feet on the sea level. And so this building is definitely in the water at this point. So it's entirely likely that by the time we die, that this building will be in the water. So, any questions? Anybody not believe that? Yes. It would be like Venice. So that's one of the big things that's having an effect on the insurance industry right now, is because when people start to budget out 30-year lifespans of buildings, you're having to look at taking into account a 100+ foot sea level rise. So you're going to have to be all Dutch and get a whole bunch of, barriers. Okay. Sorry, this isn't as technical, but yeah. Mm-hmm. Yeah, so that's the speculation on why that is because the ecosystem hasn't had a chance to stabilize itself. You're pumping a lot of greenhouse gas into the atmosphere, but the ice glaciers that will melt because of that just haven't yet. And so there's a lag between the effect and the cause. There's about a 40-year lag. That's the speculation. But oh yeah, we're already going to experience this. Like, that's inevitable. It's just a matter if we end up here or here. Potentially, yeah. Yes, significantly. 15 to 10 years? I would say that we will start to see that. I would say that the drought will become a normal. A drought year will be the normal year, and a wet year will be abnormal. Sure, absolutely. Yep. I mean, it's stuff like Sandy in New York, where the hurricane hit New York, which is crazy that it went up that high. That will be pretty common. Yeah. So sea level rise is a lagging indicator. And so I hope that it will take longer, because we will figure out a way that we can stop stuff quicker and prevent the lagging indicator of glaciers melting and icebergs melting. No, it's primarily from greenhouse gas effect, and not, so right now Russia can actually ship stuff through the northern passage because, yes, no, that's true. It's primarily from solids becoming liquid. Okay, so fun fact. So conclusion, no matter what, in the next 35 years, we will stop adding carbon to the carbon cycle. So that's that original 8 gigatons of carbon, which means, all right, so we got to figure out what we're going to do. So this is the US energy use. It's produced by Lawrence Livermore National Labs every year, and it's one of my favorite charts because it's so much graph porn. It's amazing. All right, so we use about 80% fossil-based sources of fuel in the US, and globally it's about 87%. So natural gas, coal, petroleum. Petroleum primarily goes into transportation and industrial, and natural gas and coal primarily go into electricity generation. And so we are going to have to, over the next 35 years, replace that with something. So that's a huge change. It happens in a very, very short period of time. And luckily, I'm very optimistic about that. So, think about why. Rejected energy is like lost through transmission or heat. So you're seeing 21 out of the 27 BTUs going into petroleum or gas for cars and diesel for cars being rejected as heat. And this is quadrillion BTUs, called quads in the industry. So the majority, and this is pretty normal for burning stuff, like chemical reactions, you can't capture all the heat. There's actually a lot of science on how it's impossible to capture all the heat. So yeah, so Carnot cycles and stuff like that. Okay, so globally we use about 520 quadrillion BTUs or quads, and 87% of that is fossil fuel based. So we have to basically replace about 450 quadrillion BTUs per year with alternative sources. It's a lot of construction. Additionally, we're gonna have to leave stuff in the ground that we already know is there. So this is actually a New York Times article about today, and I'm sad I didn't get to include it in this presentation, but it categorizes the number of degrees of Celsius that each additional unit of carbon added to the carbon cycle will have. And so I think it was like, we get to about 1.7 degrees Celsius with what we have currently already released, and we get to about 3.6 degrees Celsius with all the carbon that we have found so far and is currently profitable to extract. So that's Saudi Arabia, that's all the coal that we have, et cetera. And then, so this is basically categorizes where in the world all of those reserves live, and we can't get them, right? Somebody has already paid for this land on the basis that they will, and financed it on the basis that they will extract it and burn it, but it just isn't gonna happen. So that's what they call stranded assets, if you want another term. It shouldn't happen, and I will work my entire life trying to prevent it from happening, and hopefully we have cheaper alternatives. So that's where software comes into play a lot. So this is what the Rocky Mountain Institute, which is one of the leading research firms on renewable sources, has kind of said will happen over the course of the next 35 years. Oil and coal going to very little. I personally disagree with nuclear. I think that will expand and take up the place of natural gas, and renewables will replace the natural gas. So, but I'm obviously not nearly as much of an expert on that. So again, all in the next 35 years, all in our lifetimes. Woohoo! However, a lot of it is software. So this is energy efficiency technologies, integrated design. All of that is primarily driven by software. So that's what I kind of wanted to talk a little bit more about. How am I doing on time? Okay. Oh, awesome. So software. Does anybody have any questions so far? Yes? No? Okay. So approximately 60% off of the move off of fossil fuels would be driven by software, which is awesome. You know software. So the current generation of software is very slow and manual in the energy industry. It's primarily spreadsheets and custom-built Oracle applications that are for that facility. This is actually the leading software component in the solar industry right now. It's called PV-Syst. And so you would think that all of this new technology like solar would have more advanced interfaces, but it doesn't. It's currently very, very slow. You have to have an engineer type in all of this information in order to generate a predicted solar panel. You have to draw out all of the design information in CAD in order to generate engineering documents. And then you have to do most of the data science in the energy industry is done via spreadsheets. So it's no Hadoop or big data or anything like that, fortunately. Questions? Mm-hmm. So that's actually one of the things I wanted to talk about today is the energy industry is by no means any sort of expert in data analysis or data science or even scaling a large amount of data, or even if that will help. So that's one of the things that I wanted to hear feedback on the room for is we are not educated in this field. And yet we have to grow by whatever it is, 200x in the next 35 years. So that requires a lot of scaling expertise. Yeah, yeah, mostly. There's also, so solar currently is about 50% soft cost and 50% hardware cost. And so that means that the 50% soft cost, which is your permitting, your engineering, your cost of customer acquisition, your marketing, your overhead, like everything that's not labor and manufacturing, that is, I think, going to have to be, the savings from that, the price reduction in that to make it more competitive is gonna have to come through software. That's actually what I work on now. So that's my startup, is focusing on customer acquisition costs for solar and energy storage. So probably not fusion in the next 35 years, maybe from 2050 to 2100, but you know, that's beyond, that's next generation's problem. This generation's problem is, I think nuclear is going to be primarily fission driven. And there's a lot of generation 2 nuclear startups that are trying to find a way. The big problem is that they're still really expensive. It takes $250 million to get a permit for a next generation nuclear facility. And so that means that you, as a startup, have to go raise $250 million before you can build anything. And so that's a little bit of a barrier to entry. Yeah, exactly. So that's why there's so many nuclear startups now, is because a lot of VCs have decided that this should not happen, that it should get wider, which I'm 100% okay with. Like the second generation nuclear is actually very passively safe, and it's self-cooling, so no pumps or anything like that. And they're actually pretty small. So you can basically get 100 of them and bury them in the ground, and they just burn for 100 years. So yeah, so the second generation, the startups that I'm referring to, so background on nuclear, cold water reactors are the current generation, and that's what's been in the industry since like the 60s. And that is still not passively safe. It's still got, you know, significant issues, but it's currently permitted. And like I said, it takes $250 million to permit a new design. And so that's what everybody just builds. No, yeah, nothing has actually been built of these new designs. There's a lot of science, there's a lot of MIT grads, but there's not a lot of hardware in the ground yet. And so the expectation is by 2025, we start to get there. We start to get these things permitted and pilots driven, and then by 2030, hopefully we get some of the small modular nuclear in the ground. But that's still, that gives solar and wind 10 years of a head start in price competition. And so current nuclear is expecting electricity prices to be where they are now, and the solar industry is expecting them to fall by 50% because solar will just be that cheap. So I'm skeptical. I would love for nuclear to be a part of it because it's a great source, and we're, you know, a civilized society and we should control the atom. That's awesome, but it's not, it's all about price. Yeah? So that's where we're living now, and it sucks, and we need help. And this is where it currently is moving. So this is the next generation. This is my startup, UtilityAPI. This is another local startup called Helioscope that is doing like automated CAD work in Google Maps in the cloud. And this is another local startup called OhmConnect. Has anybody ever heard of these startups? Okay. OhmConnect, which does aggregated demand response. So one of the big problems in the utility world right now is that you have about a 50% load capacity, which means that 50% of the grid is producing power, and then the other 50% is just sitting there because if there's ever any air conditioner spike or anything like that, it needs to just turn on and go. And so it's built to be at the peak. And one of the interesting technologies that's with smart grids and communications and demand response is that you'll be able to have a higher load capacity on your grid because if there's ever any event, you send out a signal to this company, and then they actually have integrated with all the Nest thermostats and the Teslas of homeowners, and they pay the homeowner $20 to pause their air conditioning for 15, 20 minutes. So that's what's called demand response. So stuff like that, better communication. This is moving into the much more automated life cycle. So we're doing an API where you can basically just API request information from the utility, and it comes back to you in an automated fashion. So that's much, much faster turnaround on quotes, on analysis, sort of thing. No, it's meant for companies. So this would be baked into like a SolarCity quoting app or something like that. Exactly. So if you're going to any Home Depot or Lowe's, which I highly suspect not many of you do, but if you're like most people in the US, you're probably going to Home Depot or Lowe's pretty often, and there is likely a person, whether or not from either SolarCity or one of the other companies, that is standing there and is like, hey, do you want to go solar for free? And a lot of people say, tell me more. And currently that life cycle is, okay, I need to see your billing history from the utility. And that means you have to set up a call, or you have to do a home visit, or you have to like schedule something later, and that basically halves your sales funnel. And so one of the things that's beneficial with an API is you can actually get that there in the store, generate a quote in the store, and somebody walks out with a purchased solar. Anyway, so that's the benefit of having something like that. That's where the 50% soft cost gets reduced. Next 20 years, artificial intelligence. This is super awesome. This is really, really fun stuff. So self-driving cars, neural networks for grid prediction. That's the little bit of the load factor that I was talking about earlier. This is actually California ISO, which is like the major grid operator in California. They're implementing a whole bunch of neural network stuff to do load prediction. And it's basically the predicted versus the actual on this. One of the big problems with intermediate sources like solar and wind is that you have to have very good prediction algorithms so you can ramp up and down. And that's actually where a lot of storage comes into play, because you can send out a signal 30 seconds before a cloud passes overhead because the neural network figured out of the cloud patterns for that day, and send out a signal to all the Tesla batteries sitting in people's garages and saying, hey, start pumping stuff onto the grid because we're going to get a big solar shortage in the next 30 seconds. So that's really, really cool stuff. And that goes into all of the smart grid connected technologies. So sensors are getting super, super cheap, and also demand response signals are getting super, super cheap as well. And so you will be able to communicate through all of these networks for a higher load penetration. The other thing that I think is super, super cool is self-driving cars combined with EVs, combined with demand response. And so if you think about it, Uber has a fleet of cars that nobody owns. You just call an Uber and you get it. So you're going to see fewer and fewer people owning cars and just using a service to get around. And then all of those cars are eventually going to transfer over to self-driving, right? And they're probably going to be electric, which means that the driver, since they don't have a driver, they can just pull off to the side of the road anywhere and charge. And so they can basically be running 24/7, which reduces your amount of cars on the road by something ridiculous like 40%. It's crazy. And so you don't have to build new infrastructure. And one of the big contributors to greenhouse gas emissions is concrete, or I guess technically it's cement, because that's the chemical reaction that releases the carbon. But concrete is the bulk of, so you don't have to build infrastructure, you don't have to build buildings, you can deal with existing road infrastructure using self-driving vehicles as a leased service. And using that as a demand response. So basically the utility, California ISO, could say, hey, like fleet of self-driving cars, I need 20% of you to pull over and shove 20% of your battery back on the grid right now, and I will pay you whatever for that, which is also really cool. Yeah. Yeah. So this would actually be coming from the ISO itself. That's one of the things that Ohm Connect is doing, is they actually buy in as a generator. So they represent themselves to the market as a generator and basically say whenever the grid says, I need 1 megawatt of generation, they will bid in and then send a signal to all of their connected devices, turn them off, and that effectively lowers the demand by 1 megawatt. No, it goes directly into the ISO. That's how you get the money out. So yes, I think that PG&E will eventually have demand response specific programs for territories, but currently that is just national grid or like regional grid stuff. So state of California, Nevada, and Oregon. I don't even know if they go into Oregon. That's a good question. Okay. So thoughts so far? I think it's going to be super exciting. There's a lot of stuff that needs to happen. Am I doing on time? Okay, what's needed from Twitter? Number one, education. We are energy people. We are not very conversive. We are not very sociable. We need to be. So not a lot of people know that solar has reached grid parity in a lot of different places and actually is viable. Grid parity means that the unsubsidized cost of electricity from installing solar is less than you would be paying to the grid. So it's basically the price matching without subsidy. And so currently in California, where there's a lot of sun, it's about 12 to 13 cents a kilowatt hour. And so if you're anywhere above tier 1 in PG&E for residential, you would save money by switching to solar. So that's, yes. Yes. So California instituted a 10-step program. I think it was Arnie that did it like 10 years ago. And that basically said that for the first 100 megawatts of installed capacity, we will give this subsidy. For the second, we will give a little bit less, a little bit less, a little bit less. And I think PG&E left the last step a year and a half ago. And so there's no more subsidy in California or state subsidy for solar in PG territory. I think there's a little bit left in Central California, but this is no longer a subsidy-driven industry, which is awesome. Actually, that's actually why one of the biggest things that I don't have on this list is finance. So Wall Street has discovered that it is extremely profitable for people to go solar, and they have things called yieldcos, and yieldcos are basically bundled lease assets for solar, and they generate 7 to 8% yield annually, which is incredibly awesome because mortgages are like 4 to 5%, and that's basically the same level of risk that you have because it's installed on your house. And so it's a much better return. And so there's a lot, financing a project is super easy. Like if you meet the bare minimum requirements, you never have a problem getting a loan for solar. What is a problem is that not enough people know that that exists. So things from Twitter that I would encourage you guys to help out with and give advice on, and since you're popularity experts, that this is an area that the energy industry, especially new energy industries, need help on. We have this awesome product. We have no idea how to market it effectively. We're trying, and we're spending a lot of money on it, on trying to do it, and I don't think we're near good enough as we could be. And then also the other thing is, like, how many people were surprised that all this was going to happen in the next 35 years? Okay, good. Everybody here is educated. A lot of people don't. A lot of people they think it's some, like, their kids are going to have to deal with a thing, and it's not. Yeah. Yeah, so stuff like that. I mean, right. Exactly. So the general consensus is that political action probably won't happen for the next 10 to 15 years. The economic action is probably the most viable action that you can take in the next 10 to 15 years because it is profitable and it is easy to get financing for it. And so the competitive nature of wind and solar are probably going to have the biggest impact on reducing the amount of sequestered carbon entering the carbon cycle in the next decade. But after that, we will start to see much, much more substantial effects. I think the California drought is probably the biggest example, the most tangible example. Farmers are probably going to have to restrict water usage or build a ton of desalination, and that's incredibly expensive. So the economic impact of doing that in California over the next decade will eventually basically flop the entire population over into carbon taxes and stuff like that to severely limit the amount of carbon entering the carbon cycle. The second thing is scale. So scale is a problem that we currently, energy used to be very decentralized in the sense that the data that was contained in a coal power plant just sat on some server or was just on a printout, I kid you not, like a seismic printout for amount of generation and just stored in a roll in a back room. And so now that we're starting to try and increase load capacity on the grid, all of that information needs to be shared around. And so to give an example, there's 4 to the 15th minute intervals per year in the US. So that's, I think, 31 million minute intervals in a year times 130 million meters. And so that's kind of like your annual input rate for this sort of service. And that's going to have to be dealt with on a basis. And I'm sure that you guys have a lot of experience at large data feeds. So I would guess that that's not anywhere close to the amount of data that you guys take in. Yes? I don't know. Okay, I can't really, obviously can't comment on it, but anyway. The other part is data analytics. So it's very mature in tech, so you have a lot of marketing analysis, a lot of behavior analysis. Yep. Yeah. So every smart meter, so it's typically 15 minutes, but the smart meter itself, I think, collects every 4 seconds. Yeah. Yeah, so about 45% of the meters in the US are digital now, and that's expected to go to 100% over the next 10 years. The ones that are analog, you're right. A guy comes around and takes a look at it and writes it down and goes back in, so there's 12 data points a year. The digital ones, usually the way they work is they have a Zigbee radio on it. And so that's a low frequency radio. So they store up information and then a truck drives around and collects all the information from all of the radios that it drives by. So it's much more efficient that way. Another type of smart meter actually uses a mesh network. So it is able to send the data hopping through smart meters to the central node. And so you just basically install a central node and all of your smart meters in houses and buildings are over that. It's pretty rare that you have a smart meter that has a cellular signal or cellular radio in it. Yeah. Yeah, so generally the local 4-second intervals are only available simply due to bandwidth restrictions. Like you can't hop through 10 meters with every 4 seconds. So those are usually local. I think there's a device called Rainforest that you can connect to your PG&E smart meter, depending on the smart meter, that will give you 4-second intervals, but that's just straight from the meter into the device. And the PG&E just gets the 15-minute aggregation. Exactly. Yeah, so there's a big part of the industry called disaggregation, which basically takes a raw meter feed, either minute or sub-minute, and parses out, oh, that's an air conditioner, that's a fridge, that's a toaster, cetera, from that one data stream. And so you're doing a lot of statistical analysis. But we're not any good at it. Like I wouldn't categorize us as being experts on any of this, especially in the utility. Like, I'm sorry if anybody here used to work at a utility, but it's there's not a whole lot of incentive to get better at this. There is a lot of incentive in the private sector. That's where I see a lot of hope is there's a lot of incentive to get better at this. And so I wouldn't be surprised if a lot of the tech that comes out of Twitter is used for data science in. No. Yeah, yeah, and probably the majority of the reason for that is because there's a huge brain drain going on. So a lot of younger, talented individuals who would have probably been power engineers in the 60s, 70s, and 80s are figuring out that they're going to have much, much better and successful careers in alternative. You're seeing a lot of talent go into solar and wind and demand response and stuff like that. Okay, the last one is participation. So we have a hackathon coming up next week. I'm in a solar software accelerator called SfunCube. The companies in there build specifically solar software. And we're having a hackathon next weekend. I would love to have a lot of tech talent participate in that because we're looking for more ideas. We're looking for great challenges. Another one is Hanergy, which is a Chinese manufacturing or energy company. They recently bought a thin film manufacturer in Palo Alto, and they're having a $500,000 design challenge. And there's only 15 submissions so far, and they're really not good submissions. So if there is a design team here that wants to make an easy 120K, you could probably submit something to that, and it would be awesome. The next thing is there's a big conference in San Francisco this summer called InterSolar, and there's probably going to be a hackathon at that as well. So this is a great way to kind of, on your weekends, if you're interested in maybe contributing a little bit to this industry, doing hackathons, doing design challenges, that sort of thing, I think would be a big help because there's a lot of talent here that I think has a lot of time to contribute to this sort of thing rather than, I don't know what you guys do. I do these things. The second thing is political support. So the tech industry, one of the biggest laggers, like I mentioned earlier, we're not expecting political support in this industry for the next decade or so, especially on the federal level. And so any sort of help from other industries that we could get in pushing that forward, so it's not 10 years, it's 8 years or 5 years, I think would be a big support. I don't think anybody in the room really has the capacity to do that, but I'm gonna keep saying it. Okay. It's called the Thin Film Solar Challenge. It's on, so SfunCube is running that as well. SFUN Cube, which is also a terrible name, but whatever. I didn't choose it. So it's actually an acronym. It's Solar for Universal Need is the acronym. It's fun. Anyway, so that's basically what I had. I encourage people to talk up on thoughts that they have previously had on the industry, what they learned, and has anybody really thought about energy to any large extent as far as an industry? Yeah? Anything in particular you think I didn't cover? Oh, yeah. Yep. Mm-hmm. Yeah. Selling to utilities is really hard. Yeah. So luckily, nowadays, that's no longer the case for software. Primarily, the growth for the software industry now is towards private sector or behind the meter company. Awesome. Sorry, behind the meter means anything that the consumer is paying for themselves. So that's not the utility. You're selling to the end consumer of the electricity. So that's your Nest thermostats, your Teslas, your solar cities, etc. So they're selling directly to consumers, and they have a financial incentive to make their experience spectacular. If you're selling to the utility generally has to go get a rate case approval through the Public Utilities Commission before it has the budget to buy anything. And so you have probably anywhere from a 4 to 5 year turnaround time to actually getting the budget to sell anything to the utility. So traditionally, like you mentioned, selling to utilities is really hard because they either have the budget already and already have a procurement officer that is out to get that thing, or they don't have the budget for it. Nope, we sell to solar companies. Solar companies pay for the API and solar companies pay for the design tool. So, and then Ohm Connect just buys directly into the ISO. So none of these companies make money from utilities. That's generally kind of in the automation world, automating stuff through utilities is really hard. So there's, the top 10 solar companies make up about 50% of the market. And then there's probably 2,000 or 3,000 on the other side of the market. So it's a lot of like local electrical engineering shops that have basically just gotten their certification to install solar. And so mom and pops, small shops, small teams make up, it's a very long tail. That's expected to change over the next decade, where a lot of the bigger shops are expected to just buy up or get market share. So who knows? Depending on it, primarily because soft costs are going to be such a determining factor in cost that your efficiencies of scale on the larger companies will basically win out over the smaller companies. Yeah. Bloom Energy, didn't they get bought? They're the storage company, right? Oh, I don't know. I'm not really sure. So biofuels kind of fizzled out. It just wasn't cost competitive. Okay. Cool. Oh, yeah. Well, these guys. It's fuel cell stuff. Yeah, fuel cells is still around. Applications are pretty limited. But it's still around. Yeah. Probably not. So if you look down here, hydrogen's actually right here. Very, very small slice, primarily because most of the hydrogen comes from fossil fuels right now. Yeah. Then you already have solar power. So hydrogen is really not that good of a storage medium, especially if you're able to very, very cheaply manufacture lithium ion or aluminum cells, but or like compressed air, flywheels, all of that stuff is cheaper than hydrogen. So unfortunately, the chemistry and the properties of hydrogen itself just make it really hard to store, and that's what you would use it for, is storage. So well, I would be pleasantly surprised if a carbon-free source of hydrogen became super cheap and super effective. I think I'm 100% behind that, but I doubt it'll compete on price. Yep. So pumping water, so I guess that's potential energy storage, like pumping water up a hill, is pretty much all tapped. So a lot of the water storage locations, like valleys, et cetera, have already been built. And you would literally have to dig out a valley if you wanted to build another one, which is very expensive. The reason why water storage is so cheap is because you already have the existing geography to do it. But once you run out of that, it's hard. So places like Costa Rica are pretty much primarily hydro, and it's awesome because that means their carbon footprint is extremely low, but they just have the natural ability to build dams wherever they want. Because there's a lot of valleys in Costa Rica. I would say transportation is a big one. The other thing, so making sure your employees can have a low carbon way of getting to and from work. Remote work is actually incredibly effective at doing that because you just don't go anywhere. I don't know what the policy here is about that, but where is it? Okay, the other one is education. Twitter has a potential to have a much bigger impact than the energy industry. And so participation by Twitter to basically promote these low carbon things and promote them in a way that is effective is probably the biggest impact that a place like Twitter could have. And so that's, sort of my plea is that the energy industry can't do this by themselves. There's so much, we have to replace 87% of the world's energy in 35 years. That's laughably large. And so we need all the help we can get. And education is probably one of the biggest bottlenecks. Money isn't the bottleneck now. It's actually scaling. I mean, so O-Power has been around for probably 5 years at PG&E, and they say that they have a 1% behavior rate change impact on, So behavior change is very difficult when you're just trying to change behaviors, when you don't have something that you can just point to and say, buy that, not this. That's a much better driver. So switching people to something is a much more effective driver than just saying, change your behavior. Because oftentimes people would just go for the thing that's easier. So you actually have to make it easier. And don't get me wrong, I would love to try behavior change as much as possible. I don't see it as being nearly effective as actually coming up with an alternative that is easier. Yeah. 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 So the primary drivers for carbon footprint in the world are probably going to be developing countries, so India, China, and those two countries are actually having huge solar initiatives. So India just announced they are going to shoot for 100 gigawatts by 2020, which is a fuck ton of solar. And China is basically shutting down all of its coal and building nuclear and wind and solar nonstop because their citizens are just getting polluted so terribly. So they are in my opinion, the developing world is actually responding better than the developed world. primarily because there's not nearly as much entrenched business interest in the system as there is in the US and Europe. So like Europe is still addicted to natural gas. So it's going to have to find a better way to heat homes in the winter if it's going to do that. Solar in Germany has primarily taken a lot of that, produce a lot of heat from solar in the winter. And so it's picking up. I would say the US is primarily the driver of, or has a lot of the innovation in software. So if there's going to be an export in this economy from the US, it's probably going to be technology and software. Probably not going to be manufacturing. Batteries is kind of another thing because they're really heavy, and so you're probably going to have quite a bit of battery manufacturing in the US just because you're having to make so many batteries because you're going to replace all of your cars over the next 35 years. So that'll be fun. Sure. Yeah. Mm-hmm. Yeah, so I would love to hear alternative ideas about how like some other technology can come to fruition. Electric cars, the main reason why electric cars suck is because they don't charge very fast. So if you think about how many megawatt hours of energy you're transferring whenever you fill up your tank, it's something like you're transferring at a rate of like 3.5 megawatts. That's when you're just like fueling your tank. And so transferring that over a wire via electrons is pretty hard, like technically hard. And so I see electric cars as becoming swappable batteries. Like the whole gigafactory, having batteries in the home, all that sort of culture is just going to make batteries so cheap that you just have 2 or 3 at your house and you can swap them out via whatever sort of automated robot. Or you can just stop by a station and it has an inventory of batteries that you swap out. That also works incredibly effectively if you have a automated set of self-driving cars, because you can just have drop-off points for that. And since nobody's in the car, you don't have to worry about. You can do that on your way to the next pickup. You don't have to have a passenger since there's no driver. So fleet vehicles are incredibly effective for electrification. Yeah, we're at time, but thank you very much for sitting this out. I know it was kind of hard to sit through the first half because it sucks a lot, but I think that there's a lot of opportunity and a lot of economic growth that's going to happen. So currently the solar industry employs more people in California than the utility industry, and 1 out of every 78 jobs last year was a solar job. So it's the fastest growing industry in the country, primarily because it has no more money problems. Yeah, thank you very much. And there's a hackathon next weekend. I don't know if I mentioned that, so come to the hackathon.